Welcome to this lecture on term frequency and inverse document frequency. So in this lecture, we are going to see what is TF-IDF method in NLP and what are the types of method we have for converting a given document into a vector form. So we have methods like count vectorizer, TF-IDF, and bag of words method. Then word embeddings to convert a given document into vector of words. So we can generate vectors from a given PDF document or .txt document or from a Word document. So we will see how to apply this TF-IDF technique, and we'll also compare with the bag of words method. So first, let's see what is TF method. So the basic count vectorization method usually uh, counts number of times a particular term appears in a document. So given a document, first we'll apply tokenization, we'll generate vocabularies tokens from the given document or sentence, and then after generating vocabularies, we will check how many times whether a term appears in a document or not. We'll check. Based on that, we'll set the count for each word in the document. Whereas in TF-IDF, it captures interesting information, analyzing the importance of word within a document, and also it considers measuring the importance of the term across all documents in the corpus. So here we combine these two, term frequency and inverse document frequency. Term frequency refers to a way of capturing importance of a word within a particular document. So it should be calculated applying this formula. Number of times word appears in the document divided by total number of terms in the document should be calculated. Inverse document frequency, we calculate log of total number of documents divided by number of documents that contains term t. So if the IDF score is low, then term appears in many documents. If the IDF score is high, then that means that the word appears in fewer documents. So we'll multiply these two values, TF-IDF, to get the score, and we'll analyze the features in the uh, next stage by applying machine learning or deep learning techniques on the vectors that we generate. So in this method, vectors are generated uh, by generating weighted scores using TF-IDF method. So it is applied for document classification, for example, to generate features from a given document. So we have to convert a given document into numerical features. Then only we will apply machine learning model for document classification or clustering. Similarly, in search engine, Google search, this mechanism is used to rank documents based on the relevance of the word in the search query or in the document. And for text similarity also, it is used to compute the similarity between documents. So based on common words or common phrases, so it generates uh, similarity score. So now let's consider uh, a formula for calculating this TF-IDF. So we'll multiply these two for a given document. We consider how many times word appears in the document, and the inverse document frequency considers how the terms common to across the documents in the corpus. So if the score is high, then it is important in a specific document. So the words are not common. So, but no, the words are not common across the entire corpus. So the score is low, then that means that the word is common across documents. For example, these are all common words, the, is, in, of, and these are all some common words that are used in the English language. So let's now consider an example. So we have three documents. The first document contains a sentence, the cat sat on the mat. The second document contains a sentence, the dog sat on the mat. And the third document contains the sentence, cats and dogs are great pets. So let's now calculate the term frequency. So for cat in document 1, if you see it appears one time in document 1, so out of 6 words it appears one time. So 1 by 6 we get 0.167. Similarly for calculating TF-IDF and for calculating TF of mat in document 1, so if you check this word mat, it appears one time in document 1, and there are 6 words in that document 1, so out of 6 it appears one time, 1 by 6 we are getting 0.167. In the next step we are calculating IDF score, IDF of word cat and mat. So IDF for cat is log of 3 by 2 because uh, cat appears in document 1 and 3, so we here consider the word occurrence across documents. So out of 3, total time, so 2 times it appears, so it appears in 2 document, so 3 by 2 we are getting 0.176. Similarly mat appears in document 1 and 2, so out of 3 documents, so mat appears in 2 documents, so 3 by 2 it gives 0.176. Now we will multiply these values for term cat in document 1, so we get 0.167 into 0.176, it gives 0.0229. Similarly for the TF-IDF score of the term mat in document D1, we get 0.029. So from this example, if these words cat and mat have the same IDF score in document 1, because the term cat appears only in document 1 and 3, mat appears in document 1 and 2. So these are somewhat important and the specific documents which are appearing in the document, 2 documents. So both the terms are relatively common in this corpus, so it results in a modest TF-IDF score. So if you had a term that appeared only in one document but not in the others, then IDF score would be higher. So in bag of words method, it counts the occurrence of a word in a document. So for each word, it checks the occurrence of a word in a document. It treats all words as equally important words, and without considering their relationship, it counts the number of words in the document. Whereas TF-IDF adjusts the importance of the words by considering TF and IDF scope. It helps to highlight words that are significant to specific documents and downplays common words which are occurring across documents. And word embedding also captures important relationship between words. So this applies for a task where you want to distinguish important words from common ones, then we'll go for this TF-IDF method. So it is very useful in search engine, document retrieval, and topic modeling. Whereas if you want to perform simple tasks for like document classification or document similarity checking something, then you will go for checking how many times whether a term appears in the document or not. So the check the presence of words in the document. In that case, we will go for bow method or bag of words method. So if you consider word frequency, then In bag of word method, it counts how often a word appears in a document, but TF-IDF generates weighted score of words by considering the importance across the corpus. And if you see common words, dealing with common words, so all words are treated equally in bag of words, whereas in TF-IDF it reduces weight for common words appearing in multiple documents. So if you see sparsity, so this bag of words generates a highly sparse matrix representation for given set of documents. So it checks each word appears in the document for the vocabularies. So there may be many zero values which causes high sparseness, whereas TF-IDF reduces less frequent words. Sorry, less frequent words are given higher importance. Weighted score is higher for that, whereas common words are given uh, less score, so there will be less sparseness. If you consider word importance, here there is no concept of word importance based on the corpus, but TF-IDF method consider the importance of a word in relation to the entire corpus. So for simpler tasks like document classification or document clustering, we'll use this word count method, bag of words method, whereas for better classification task, information retrieval, topic modeling, we will use this TF-IDF method. It will distinguish important words across the documents in the corpus. So the output representation of this bag of words method will be a vector of word counts for each document, whereas in TF-IDF we generate a vector of weighted scores for each word in a document. So that's all guys in this lecture. Thank you so much.